Hello everyone, this is Abzalur Rahman. In our today's class, we are going to discuss about Bohr's atomic model. In our previous class, we have discussed about Thomson's atomic model and Rutherford's atomic model. Okay. So before proceeding towards this Bohr's atomic model, first of all, we'll discuss the limitations or the drawbacks of Rutherford's atomic model. That we have already discussed in our previous class. Okay. So आज का टॉपिक ये बोर्स मॉडल पढ़ने के पहले हम लोग लिमिटेशंस देख लेंगे रदरफोर्ड मॉडल का. ये रदरफोर्ड मॉडल क्यों फेल हुआ था? बिकॉज ऑफ सम मेजर लिमिटेशन. द फर्स्ट लिमिटेशन वाज दैट रदरफोर्ड ने क्या बोला था, जो इलेक्ट्रॉन जो है, दिस इलेक्ट्रॉन इज रिवॉल्विंग अराउंड द न्यूक्लियस इन ए सर्कुलर पाथ. ओके. बट मैक्सवेल बोल के और एक साइंटिस्ट थे, ओके, जिनका एक फेमस थ्योरी मैक्सवेल्स इलेक्ट्रोमैग्नेटिक थ्योरी ऑफ रेडिएशन. वो क्या बोलते हैं, वो बोलते हैं अगर कोई चार्ज पार्टिकल किसी दूसरे चार्ज पार्टिकल की इन्फ्लुएंस में अगर रोटेट कर रहा है, रिवॉल्व कर रहा है, देन इट विल एमिट एनर्जी. So, in case of Rutherford's atomic model also, okay, Rutherford says that the electrons revolve around this nucleus. Now, this electron being a charged particle, okay, it will, according to Maxwell, it will also radiate energy in the form of radiation. Now, अगर ये electron अगर energy radiate करता है, then it will ultimately lose energy and it will ultimately fall into the nucleus. Okay, suppose अगर इसको हम लोग atom मानते हैं, okay. Now, if suppose this electron is revolving in this orbit, okay. So being a charged particle, it will emit energy in the form of radiation. अगर वो इलेक्ट्रॉन अगर एनर्जी एमिट कर रहा है इन द फॉर्म ऑफ रेडिएशन, then it will lose energy and ultimately it will follow a spiral path and it will ultimately fall into the nucleus. और अगर ये इलेक्ट्रॉन जाके न्यूक्लियस में गिर जाता है, then the stability of this atom will vanish. Okay, ये एटम स्टेबल नहीं रहेगा. Okay, so this is the first limitation. Okay, ये रदरफोर्ड एटॉमिक मॉडल ये एटम का स्टेबिलिटी को एक्सप्लेन नहीं कर सकता है. फर्स्ट नंबर 1. ओके, सो ये जो लिमिटेशन, ये जो एरर, ये किसने निकाला? मैक्सवेल ने. ओके. एंड नंबर 2 इज दैट दिस मॉडल ऑफ एटम, रदरफोर्ड्स मॉडल ऑफ एटम कैन नॉट एक्सप्लेन द डिसकंटिन्यूअस स्पेक्ट्रा. एक एटम का जो डिसकंटिन्यूअस स्पेक्ट्रा है, इट कैन नॉट बी एक्सप्लेन विद द हेल्प ऑफ रदरफोर्ड्स एटॉमिक मॉडल. ओके, सो टू सॉल्व द स्टेबिलिटी, एक एटम का जो स्टेबिलिटी है, इसको सॉल्व करने के लिए एंड टू एक्सप्लेन द लाइन स्पेक्ट्रा ऑफ एटम का जो लाइन स्पेक्ट्रा है, दिस टू ड्रॉबैक्स, ये दोनों को सॉल्व करने के लिए बोर ने क्या किया, दिस नेल बोर अप्लाइड Planck quantum theory of radiation to Rutherford's model and he gave his own atomic model. Okay, so Bohr ने क्या किया, ये दोनों प्रॉब्लम, the stability of atom and line spectra of atom, ये दोनों टॉपिक को, ये दोनों ड्रॉबैक्स को सॉल्व करने के लिए उन्होंने क्या किया, उन्होंने किसी और एक साइंटिस्ट मैक्स प्लैंक, उनका एक फेमस थ्योरी है प्लैंक्स क्वांटम थ्योरी ऑफ रेडिएशन, उसका कॉन्सेप्ट रदरफोर्ड एटॉमिक मॉडल का जो कॉन्सेप्ट है उसके साथ मिक्स किया. ओके, करके उन्होंने एक नया मॉडल ऑफ एटम दिया जिसको हम लोग क्या जानते हैं, बोर्स एटॉमिक मॉडल. ओके. So, what are the postulates of this atomic model? The postulate of this Bohr's atomic model is that number 1, an electron in an atom revolve around the nucleus in a limited number of selected orbits. रदरफोर्ड ने क्या बोला था? रदरफोर्ड ने ये बात बोला था कि एटॉम जो है, इलेक्ट्रॉन जो है, दिस इलेक्ट्रॉन्स रिवॉल्व अराउंड द न्यूक्लियस इन ए सर्कुलर पाथ. जस्ट उन्होंने ये बात बोल दिया. ओके, बट उन्होंने मेंशन नहीं किया whether these electrons are rotating. He has not mentioned the exact position. He has not mentioned the orbital, okay, or the energy levels. Okay, but this Bohr says that, Bohr ने क्या किया, Bohr ने बोला number 1 is that this electron revolves around the nucleus in a limited number of selected orbits. Bohr ने orbits को mention किया, मतलब ये जो इलेक्ट्रॉन है, this electron will rotate in a limited number of selected orbits. कुछ orbits में वो this electron will rotate. Okay, so and these orbits, he called these orbits as stationary shells or energy levels. Okay, so the first postulate of Bohr's atomic model is that an electron revolve around the nucleus of an atom in a limited number of selected orbit, in a limited number of selected orbits, and these orbits are called stationary shell or energy shell or energy level. Okay, सो बोर क्या बोलते हैं? बोर बोलते हैं ये जो इलेक्ट्रॉन है, दिस इलेक्ट्रॉन, सपोज हियर वी हैव न्यूक्लियस, ये जो इलेक्ट्रॉन है इट विल रोटेट अराउंड द न्यूक्लियस इन a limited number of selector orbits. Okay, so it will rotate around this nucleus in a limited number of selector orbits. Okay, and these orbits he called stationary shells. इस orbit को उन्होंने क्या नाम दिया? stationary shells or energy shells or energy levels. Okay, suppose this is the first orbit n equal to 1, this is the second orbit n equal to 2, n equal to 3. Okay, so first orbit, second orbit, third orbit, or you can say that k shell, l shell, l m shell, n shell, like that. Okay, so he mentioned about this orbit, but Rutherford has not mentioned about the exact orbit. Okay, so this is the first postulate, number one. Number two is that this electron can revolve around the nucleus. This electron can revolve around the nucleus in those circular orbits for which the angular momentum is an integral multiple of h by 2 h pi. Okay, so he has mentioned that the electron can revolve only in those circular orbits for which the angular momentum that is MVR, angular momentum is an integral multiple of h by 2 pi. That is MVR is equal to NH by 2 pi. Where n is integer. Okay, integer. This may be 1, 2, 3, like that. Okay. So number two is that electron can revolve only in those circular orbits for which the angular momentum is an integral multiple of h by 2 pi. Okay, so this postulate gives about the quantization condition. Okay, ये जो electron है, this electron will revolve in certain fixed circular orbit. Okay, suppose here we have this atom, here we have this orbit, first orbit, second orbit, third orbit, fourth orbit. Okay, so it will follow some condition. Okay, it will follow some condition. Okay, it can revolve in the either in the first orbit, second orbit, third orbit, or fourth orbit. Okay, here this n indicates the number of orbit. Okay, now if this electron is revolving in the first orbit, okay, so its angular momentum, this MBR you can write it as L. Okay, angular momentum can be denoted with L. L is equal to, here if it is rotating in the first orbit, then the value will be h by 2 pi. Okay, L1. Suppose this electron is rotating in the second orbit, then will be L2 is equal to, here the value of N will be 2, so twice h by 2 pi. Okay, so here its value will be h by pi, like that. Okay, so he says that this electron, ये जो electron है किसी एटम के अंदर कहीं वैसे किसी पोजीशन में मूव नहीं कर सकता. Okay, so it will follow a circular path and it will move in a either in the first orbit, second orbit, third orbit, or fourth orbit. Okay, so here this value of n cannot be fractional. The value of n cannot be fractional. Okay na? So here this value of n, it cannot be 3 by 2, it cannot be 5 by 2, it cannot be like 1 by 2, like that. Okay, so it will follow either first orbit, second orbit, third orbit, like that. Okay, so here this electron can rotate only in those circular orbits for which the angular momentum is an integral multiple of h by 2 pi. Okay, and this condition is called quantization condition. This condition is called quantization condition. Means ये जो इलेक्ट्रॉन है, ये इलेक्ट्रॉन उसी ऑर्बिट में मूव कर सकता है, रिवॉल्व कर सकता है जिस ऑर्बिट के साथ उसका एनर्जी मैच होगा. ओके, दिस ऑर्बिट्स आर एसोसिएटेड विद सम अमाउंट ऑफ एनर्जी. ओके, एंड दिस इलेक्ट्रॉन विल रिवॉल्व इन ओनली इन दोज ऑर्बिट्स फॉर व्हिच इस एनर्जी मैचेस. ओके, एंड दिस कंडीशन इज कॉल्ड क्वांटाइजेशन कंडीशन. ओके, नंबर 3 इज दैट, थर्ड पोस्टुलेट इज दैट number 1, number 2, number 3 is that this Maxwell's law of electromagnetic radiation theory is not applicable to an electron in an atom. Okay, Maxwell ने क्या बोला था? Maxwell ने बोला था this electron, when this electron revolves, it will lose energy, it will lose energy. But इस बात को नेल बोर ने क्या किया? डिस्कार्ड कर दिया, ओके, रिजेक्ट कर दिया. उन्होंने क्या बोला? No energy is radiated when the electron revolves in a stationary orbit. Okay, उन्होंने क्या बोला? एक इलेक्ट्रॉन जब स्टेशनरी ऑर्बिट में मूव करता है तो देन इट विल नॉट रिलीज एनर्जी, ओके, एंड इट विल रिलीज एनर्जी ओनली देन इट विल रिलीज एनर्जी व्हेन इट जंप्स फ्रॉम वन ऑर्बिट टू अनदर. ओके, देन द लास्ट पोस्टुलेट इज दैट an electron will release or gain energy only when it jumps from one orbit to other. ओके, ये जो इलेक्ट्रॉन है, अगर ये इलेक्ट्रॉन किसी स्टेशनरी एनर्जी लेवल में अगर मूव कर रहा है, किसी एक स्टेशनरी एनर्जी लेवल में अगर ये इलेक्ट्रॉन रिवॉल्व कर रहा है, then it will not release energy. It will release energy only when it jumps from one orbit to another. Now if it jumps from this lower orbit to higher orbit, then it will absorb energy. Now if it is jumps from higher orbit to lower orbit, and it will release energy. Okay, so these are the conditions, these are the postulates that were given by Neil Bohr. Okay, so an electron will release or gain energy only when it jumps from one orbit to other. Okay, so here you can add, if the electron jumps from higher orbit to lower orbit, to, suppose here we have atom. Okay, suppose here we have atom. This is the higher energy level, this is the lower energy level. Now if this electron jumps from this higher orbit to lower orbit, then it will release energy. Now if this electron jumps from this lower orbit to higher orbit, it will absorb energy. Okay, और अगर ये इलेक्ट्रॉन जिस स्टेशनरी स्टेट में अगर मूव कर रहा है, स्टेशनरी एनर्जी लेवल में मूव कर रहा है, then it will not release energy, according to Bohr, according to Neil Bohr. Okay, so these are the postulates that were given by Neil Bohr. Okay, so first postulate was that an electron revolve around the nucleus in a limited number of selected orbits. जो बात रदरफोर्ड ने मेंशन नहीं किया था. ओके, सो उन्होंने क्या मेंशन किया? दिस इलेक्ट्रॉन विल रिवॉल्व इन ए लिमिटेड नंबर ऑफ सिलेक्टेड ऑर्बिट्स, एंड दीज ऑर्बिट्स ही कॉल्ड स्टेशनरी शेल्स और एनर्जी लेवल्स. एंड नंबर 2 इज दैट this electron can revolve in only those stationary orbits for which the angular momentum is an integral multiple of h by 2s pi. Okay, so ये जो इलेक्ट्रॉन है ये उसी स्टेशनरी एनर्जी लेवल में मूव कर सकता है जिसका एंगुलर मोमेंटम जो है वो इंटीग्रल मल्टीपल ऑफ h by 2s pi होगा, h by 2s pi. ओके, सो हियर यू कैन राइट mbr is equal to nh by 2s pi. ओके, so here this the value of n can be 1 2 3. Okay, the value of n cannot be 1 by 2, cannot be 3 by 2, 5 by 2, like that. Okay, so it cannot be a fraction. Okay, like that. So this is the quantization of energy. Now if this electron moves in the third orbit, the electrons moves in the third orbit, then what will be the angular momentum? Its angular momentum will be 3h by 2 pi. 3h by 2 pi. Okay, here this value can be 3, but its value cannot be 3 by 2, 5 by 2, like that. Okay, so its value should be a whole number. Okay, so this is the second postulate. Third postulate is that no energy is radiated when the electron revolves in a stationary orbit. उन्होंने क्या बोला? जब एक इलेक्ट्रॉन स्टेशनरी ऑर्बिट में मूव करता है, then it will not release energy. Okay, it will release or gain energy only when it jumps from one orbit to another. If it jumps from lower orbit to higher orbit, it will absorb energy, and if it jumps from higher orbit to lower orbit, then it will release energy. Okay, so these are the postulates of Bohr's atomic model. Okay, but this model of atom, okay, because of some other limitation, it has this model of atom has explained many things. Okay, but because of some of the limitations, this model of atom was also rejected. Okay, now we are going to discuss about the limitations of this model of atom, Bohr's atomic model. Okay, now what are the limitations? The first limitation is that, number one, limitations of Bohr's atomic model. Number one is that according to Bohr, circular orbit of atom are planar, but modern research revealed that an electron moves in a three-dimensional space, okay, 3D space. This is the first limitation. According to Bohr, circular orbits of atom are planar, but बोर ने क्या बोला, ये जो सर्कुलर ऑर्बिट जो है ये 2 dimension क्या, but this modern science says that these electrons moves in a 3-dimensional path, 3-dimensional space. Okay, and number 2 is that this model of atom cannot explain the shape of molecule. This model of atom cannot explain the shape of molecule. Okay, number 3 is that this Bohr's atomic model cannot explain the spectra of multi-electron atom. Okay, so this Bohr's atomic model cannot explain the spectra of multi-electron atom. Okay, this Bohr's atomic model, he can explain the spectra of atom consisting of only one electron. There is hydrogen or hydrogen-like atom. Okay, he can explain the spectra of hydrogen or hydrogen-like atoms. Okay, which containing of only one electron, but it cannot explain the spectra of atoms having multi-electrons. Okay, so it cannot explain. This Bohr's theory cannot explain. So this is the third limitation. Some other limitations are also there. Okay, so for these limitations, for these drawbacks, this Rutherford's model of this Bohr's atomic model of atom was also rejected. Okay, so with this model of atom, Rutherford calculated the radius of orbit, energy of orbit. That we are not going to calculate in our today's class. Okay, that we will discuss in our next class. Okay, so these are some theoretical points, concepts of Bohr's atomic model. Okay, so previously we have discussed about the postulates of Bohr's atomic model. Now these are the limitations of Bohr's atomic model. Okay, so because of these limitations, this Bohr's atomic model of atom was rejected, okay, or discarded, and then comes some others atomic model that we will discuss in our next classes. Okay, so for today's class, up to this, thank you everyone.